Hey everyone, so today we're going to finish constructing our efficient frontier. And this is going to be really easy and quick. All we're going to do is we're going to add another risky asset here. We're going to call this, we're going to take in Coca-Cola for this example. So we'll run that. And there we go. So you can see this is what our new data frame looks like here. And then we're going to run a new covariance matrix where we have Coca-Cola as well and its covariance. And our expected return for Coca-Cola, which is just the mean. We're assuming the past will be equal to the future. And then also the standard deviation, the annualized standard deviation for Coca-Cola is added here. So we have that, then we can concatenate it together. So we have them here. Now we're gonna just make a few changes. So what we're gonna make here is we're gonna create a new variable. I'm gonna call this number of assets. And I'll show the reason why we're showing this in a second. So we're gonna take the length of our columns. So we're gonna say pivoted.columns. And so this is going to create a new variable called number of assets, which is just the number of columns that we have. And right now, notice we have 3 columns in our pivoted data frame, Apple, Coca-Cola, and Nike. So that's going to be 3. If that was 10, that would output 10. And what I'm going to do is I'm going to remove this weights here, comment that out. And what I'm going to do is I want some random weights. So to do that, I'm going to say mp.random. And I'm going to put in the number of random weights I want. And that's going to be 3 because I want 3 assets. So I'm going to have 3 random weights. So, but the problem is this is going to output these outputs, these random weights will not sum to 1. So I'll show what that looks like here. So you'll notice that we have 3 random numbers, but they don't sum to 1. So to do that, to fix that, I'm going to create another variable called weights. That's going to be equal to weights divided by mp.sum of these weights. So essentially what I'm doing is I'm summing all these weights first, and then for each weight here, I'm dividing it by the sum of all these weights. That's all I'm doing. So I'll run that so you can see what it looks like. So there we go. Now I have 3 random weights that sum to 1. So we have that, so that's out of the way. Now I can run this data. Here we go. Put that in there, and we can have our portfolios. The next thing we would like to do is we're going to change this 1 to 1,000. So we're going to run this. So we're going to have 1,000 different portfolios with 1,000 different weights, 1,000 different expected returns, and so on, 1,000 different portfolio variances. So we're going to run that and then put that in our data. And there we go. So I'm only outputting the top 5 right now, but now we have a whole bunch of, we have 1,000 different portfolios. So I also would like to actually append. So what I'm doing in here, I'm actually appending all these different weights to this p weights variable. So I would like to see that for each of these portfolios. So to do that, I'm going to create another line here, and I'm going to say for counter, spell that right, for counter symbol in enumerate. I'll explain this in a second. Pivoted.columns.toList. So what I'm doing is I'm similar to our list up here for this range. I'm enumerating through this list. So I've taken the columns output, turned it into a Python list, and then enumerating through it. So what do I mean by enumerate? So what I'm doing is I'm counting the element in this list, and I'm outputting the symbol. So let me show what that looks like. So I'm going to print the counter, and I'm going to print the symbol. So I'll run that. And there you go. So you'll notice that Apple is element 0, Coca-Cola is element 1, Nike is element 2. So I'm outputting the counter, which is 0, 1, 2, and symbol Apple, Coca-Cola, Nike. So once I have that, what I'd like to do is I would like to take my data dictionary and I want to append some data to it. So I'm going to say symbol. I'm going to take the symbols out of here plus the weight. Spell that right. Weight. And I also would like to append, I'm going to create another for loop, a list within a for loop within a list. So it's going to be say for W in P weights. I'm taking for every weight in my P weights list up here that I've created here, which has a whole bunch of different weights given the portfolios. I'm going to append it to W counter. So I'll run that. And essentially what I've done is I appended all this weight data to this data dictionary. So I'll run this so you can see what I'm doing. So there we go. So I've added the Apple weight, Coca-Cola weight, Nike weight to each of the different portfolios and outputting the returns of volatility. So I have that. Now all we need to do is the easy part. We're just going to take our portfolios. And actually, you didn't really need to append any of these weights here. This would still plot. So I'm going to say dot plot, dot scatter, portfolios dot plot, dot scatter, and our x-axis is going to be equal to the volatility. Our y-axis is going to be equal to the returns, and I'm just going to say grid equals true. Make sure our volatility spelled that all right. Run that, and there we go. There's our efficient frontier of risky portfolio assets. So basically, we have these 1,000 different portfolios with different weightings given our expected returns and our expected correlations among them, and we've created this efficient frontier. So if you like this video, please subscribe. In our next video, in our final video, we're just going to build out our capital allocation line to our optimal risky portfolio and find the optimal portfolio for an investor.